Right, so now we're going to get into some naming of organic compounds. You see here that in the notes, I think this is on page 4 or something, page 2, IUPAC naming of organic compounds. And there's a useful little bit in the middle here. It talks about the fact that the name has a prefix, a parent part, which is the middle bit, the main part, and then a suffix, which is, I always like to call the prefix, the suffix, sort of the surname, and the prefix, or the parent name can be the first name, but the suffix definitely sort of the homologous series name, the name of the family of compounds. Number of carbon atoms goes in the parent, and which other groups are on it, sort of in the prefix. 3 basic little rules here: identify the longest chain, number the carbons in the chain to give it the parent name, and identify functional groups. I'm going to go through in a bit more detail in the PowerPoint just to apply these and see how they work. So let's jump through to the PowerPoint, and we'll start off with this slide here. Actually, we'll go one back. There's some rules for naming organic compounds. Now, before we start those, you remember right at the beginning here, we had a table where we looked at the different prefixes for the number of carbons. So what I've done is I've taken that table and I've copied and pasted it onto a slide, and I've actually added 2 more onto it. Let's look at this as a show. You need to learn this table, as I said before. I think the syllabus only goes up to 8, but I've put another 2 on here. Meth means 1 carbon in the molecule. Eth means 2 carbons. Prop 3 carbons, etc. And you just got to learn them. And we're going to go and apply them all now. So let's look at these rules for naming organic compounds. You first choose the longest unbroken carbon chain, and you use that table I've just showed you to decide the parent name or the main name, meth, eth, prop, but or something. Then you identify any branches. We've used branches already when we looked at isomers. The branches, we call them alkyl groups. The YL stands for branch. And so you can find if there's any branches in the chain. If there are, you have a look at how many carbons are in them. And then you use the same prefixes here from our previous table, but you put a YL. So if it's a 1 carbon branch, it's a methyl, 2 carbon branch, it's an ethyl. The third thing you do is you go and find any other functional groups present in the molecule. Now, we'll do these in more detail as we go through the different functional groups, but obviously we'll do 1 or 2 now. Remember, there's a full table of these earlier on in the PowerPoint. I'll just go and show you quickly. The notes has got it as well. You've got this table. So we've got all these different functional groups or homologous series with each one's got their own functional group. And you're going to need to go and identify those on your molecule and include them in the actual name. Now, if we go back to where we were, let's just find us. Here we are. So we're busy working through these. So you go and identify any functional groups, and you find their prefix or suffix. So they were in that table, there's a prefix or a suffix that goes with each homologous series, and you write them in front of or behind the carbon chain, depending on what they are. There's an order of precedence to decide for the suffix because there's more than 1 compound that is a suffix. You don't often have to use this, to be honest, but carboxylic acids and alkenes trump alcohols. They've all got suffixes, and both of those trump haloalkanes. So that's how you know which suffix to use if there's more than 1, and it'll become clearer when we do them. Now there's an important bit. You've got to number the longest carbon chain. So this one that you used in the first rule here, when you got your longest carbon chain, you numbered it, meth, eth, prop, but or whatever, you now need to number the carbon atoms in that chain, but you must number them in a particular way. You must start as close to the branches as possible. Start from the end, which is closest to the branches, so that when you number them, the branches have the lowest number possible. Now we'll show you in a couple of examples in a minute. And you've got to allocate a number to every single branch, no matter how many times it occurs. Running out of power, so let me just plug in here. There we go. I think that's done it. So you've got to put a number onto every branch to show where it's attached, but you must start numbering the carbons in the longest chain from the edge that is closest to the branches. And we'll do that in a minute with an example. Numbering wins takes precedence over alphabetical spelling. You'll see where groups are on the same carbon, You must write their names in alphabetical order. And then if there's more than one of a particular group, you've got to put di or tri or tetra. So we saw that earlier on with dimethyl. And then the very last one is you write the whole name as one word, and this is important. And then you just have a comma to put between any, if you've got more than one number, and a hyphen that separates the numbers from the words. So let's go have a look at a few examples. This is the same slide, just with some scribbling on it. Example, well, the first one I'm going to give you is 2-methylbutane. We've seen this already. So why is it but? That's the sort of parent bit of the name. That's the suffix, and this is the prefix. Why is it but? Well, the longest chain is 4 carbons, 1, 2, 3, 4, and we saw from that table 4 is but, B-U-T. What's the methyl bit? Well, the YL tells you is a branch. The meth tells you is 1 carbon. So here's your branch. It's got 1 carbon in it. So it's a methyl. But where is it? Oh, it's on the 2nd carbon. 1st carbon, 2nd carbon. Now you could say, well, hang on, if I started counting here, it would be 1, 2, it would be on the 3rd carbon. But that's what that rule says. You must always start numbering from the end that is closest to the branch, so that the branch is going to have the smallest number possible. So if you'd numbered this 1, 2, 3, you'd be incorrect. It must be 1, 2, 2-methylbutane. Then you write the whole word as one word with a hyphen separating the number from the letter. So let's have a go at the name of this. Now, obviously, if you've got your PowerPoint open in front of you, it'll be there for you to see. But it's good for you to not look at that and try and name it or work through the name with me. Longest carbon chain, whether you go this way or that way, is 3. And 3, if you remember back to the table, is prop. So it's prop. It's an alkane. There's nothing else in it, so it's propane. But it has got 2 branches. It's got a branch here and a branch there. And both of those branches are on this carbon, and it doesn't matter which way you start numbering, that's going to be carbon number 2. So it's going to be 2,2-dimethyl. You've got to put a di in front of the methyl because they're branches, so they're YL. The branches got 1 carbon in each, so they're methyl branches, but there's 2 of them. 2,2-dimethyl propane. Okay, dimethyl propane, all one word. 2,2. Always have a comma separating the numbers from the letters. So here's a little task for you to do. Stop the video here and go and try and draw those 3 structures. When you draw them, don't cheat like I did. I've used the abbreviated or condensed formula. It's better if you draw the actual carbons, hydrogens out. I know it's a bit of a pain, but that's the way you need to do it in an exam, and it's going to be better for you to try them like that. So stop the video, go and have a go at drawing these 3, and then when you've done that, come back and pick it up, and then you can check what's going on. Right, so if you go and do that, I'll now assume that you've just done it and you've got back, and so now we'll carry on. Right, so that's the first ones we did. And now these 3, you've gone and done them, you come back and check. Well, that's going to be 2-methyl pentane. Now, if you drew it the other way around, if you drew it flipped so that this branch is actually over there, it doesn't matter. It doesn't matter which way you draw it. You don't have to draw it from left to right or right to left, as long as that branch is attached 1 carbon away from the end. And that can be this end, it can be that end. It could be down here, or it could be down there, or down there. So you can draw it. It doesn't matter which way around you draw it. They're all the same thing. 2,3-dimethylbutane is going to look like this. 2. No, it's not. It's going to look like this. Sorry. 2,3-dimethyl. There's 2 methyls on this molecule. They are. There's your longest chain, which is but. 1, 2, 3, 4. And 2 and 3 refers to the positions of the 2 branches, and the YL tells you that they're branches. The meth tells you that each branch has only got 1 carbon in it. So it's 2,3-dimethylbutane. I didn't work through this one's name, but it's just pentane with a methyl group on the 2nd. So here's our last one. 2,2,3-trimethylpentane. Well, let's go and have a look. Longest chain is supposed to be 5. 1, 2, 3, 4, 5. So 2,2. On the 2nd carbon, we've got 2 branches. That one there and this one here. 2 branches. Both of them have got 1 carbon each, so they're both methyls. And it's 2,2 But then there's another methyl here on the third carbon. So that's why you've got 2,2,3 trimethyl, because there's now 3 branched groups of the same parent chain, and the parent chain is a pentane because there's 1, 2, 3, 4, 5. 2,2,3 trimethyl pentane. Right. Hopefully those made sense. Here I've drawn same. I've just given you another way of showing the formula. So let's just have a look at these 3 at the bottom. In writing condensed formulas, you will often see this. And I've actually seen this in exam papers, so it is possible that you get given it. You do need to know what it means. It's possible to show the branch by putting that little group in brackets. If you remember, if we go back, this was the pentane with 1 methyl on the second carbon. So it's CH3, CH, and then a branch. So you put that branch in brackets, CH3 in brackets, then it's a CH2. So if we go back here, CH3, CH, that was the bottom one. Here's your branch, CH3, that was up there. Then you go on to the next carbon, which was CH2, CH2, CH3. 1, 2, 3, 4, 5. That's your pentane. With the 2 methyl, your branch coming off here. This one would be 2,3-dimethyl butane. There's one branch off the second carbon, and there's another branch off the third carbon. So CH3 is first carbon, second carbon, CH, CH3, that takes care of those 2. Then you've got a CH, or you could put the H up there if you want to, and then the branch down here, CH3, and then the final CH3. Longest chain, 1, 2, 3, 4. And then this one's tricky. If you use the abbreviated formula, but you can. CH3 is on the end, then a C with 2 methyls on it. That's those CH3, 2 methyls. Then you've got a CH and a CH3, and then you've got CH2 and CH3. So that's your final. These you should get used to. You can show a branch by using brackets in the condensed formula. So if you see that, you must know what it should be. All right, now we're going to go the other way. Here I've given you 4 examples. I've given you the full structures. And what I'm suggesting is you go now and write the names. So again, stop the video here. Don't go on to the next slide so you see them in front of you. That doesn't help you much. Stop the video. Go and try and draw them on a piece of paper. Make sure you're happy with the names as best as you can. Then come back. You'll see here I've sort of combined different forms of representing the formula. Once you've drawn them, come back and start the video again and then see if you've got them right. Okay. So for those of you that have gone and done that, you've written them out. Let's work through them now and check. Okay, so ignore the scribbles for now. That one, the name would be 3-methyl pentane. So let's have a look at the name. Longest chain, 1, 2, 3, 4, 5. It's pent, so that's the pentane. Only carbon and hydrogen, so it's alkane, only single bonds. 3-methyl, that means in the methyl group of the 1, 2, 3rd carbon. Now, I know I've drawn abbreviated formula here. You really should go and draw the full structural formula. I think I've done them on the next slide as well. This one, what's it going to be? Well, I reckon we're looking at a 2, 3, 4, 2, 4 dimethyl, 1, 2, 3, 4, 5 pentane, 2, 4 dimethyl pentane. There we go. Again, in this name here, I'm just showing you that there is the branch, so that's the methyl. This one, 2, 4 dimethyl, 2 branches. Each branch only got 1 carbon, 2, 4 dimethyl pentane. Hope you can read my handwriting. There I've just shown you how I numbered the carbons. It doesn't actually matter in this case if you start numbering here or if you start numbering here. You're going to get exactly the same formula. Because this would be 1, 2, 3, 4. Symmetrical. All right, let's go and have a look at this guy. 2,2,4 trimethyl hexane. So 1, 2, 3, 4, 5, 6 carbons in the parent chain. That's obviously a branch off that carbon, and this is 2 branches off that carbon. So the second carbon, first, second, third, fourth, and the 4th carbon have got branches. All the branches are only 1 carbon, so they're methyls. So there's 3 methyls. 2 on the second, so it's 2, 2, comma, 4 trimethylhexane. Okay. And then the very last one, 2, 2, 3 trimethyl pentane. Now you might have struggled with this one because using this abbreviated formula does throw a lot of people. They think that's 3 methyl groups, but actually this carbon over here is this one. So you've got 3 CH3s, you've got a CH3 there, CH3 there, CH3 here, but this one's part of the longest chain. So that's why it's not 4 methyl groups. There's only 3 methyl groups because you've got that branch, and this one is not a branch, it's part of the longest chain. 1, 2, 3, 4, 5 in the longest chain, so it's a pentane. 1, 2, 3 methyl branches. 2 of them on the second carbon, so it's 2, 2. This one's on the second carbon, this one's on the second carbon. 2, 2, 3 trimethyl pentane. Okay, quite a sneaky one there. What I'm trying to show you here is obviously you can have a 2 carbon branch. So here you have a molecule where the branch has actually got 2 carbons. So that would be an ethyl. Eth is for 2 carbons, YL is for branch. Ethyl, 2 carbon branch. The longest chain is 6. 1, 2, 3, 4, 5, 6. But look at this. If you number from here, 1, 2, 3, 4, 5, 6, you get 6. But if you started numbering down here, so if you numbered from here, 1, 2, 3, 4, 5, 6, you also get 6. It doesn't matter whether you start numbering here or here. Either way, you're going to get exactly the same name. If I started numbering here, if this was my longest carbon chain, then this would be 1, 2, 3, 4, 5, 6. So it would be hexane, and it would have an ethyl group on the 1, 2, 3 third carbon. If you take this as your longest chain, this is also an ethyl group on your third carbon. So it actually doesn't matter whether you take this as your longest chain or this is your longest chain. Either way, you get exactly the same name. Now you need to be careful with ethyl groups because you can't have an ethyl group 1 carbon from the end. If you looked at this molecule, you might be tempted to think that this is an ethyl 1, 2, 3, 4, an ethyl butane, but you'd be wrong. Remember, the rule says you've got to find the longest carbon chain. It doesn't have to be straight because remember the chains aren't straight anyway. So the longest carbon chain in this molecule is actually 5 carbons. 1, 2, 3, 4, 5, the red numbers. The blue numbers aren't the longest chain. So if this is your longest carbon chain, then this must be a branch. So it's a methyl group and it's off the third carbon. So it's 3 methyl pentane. Okay, that's the only correct way to number. So here I think is the it's the same ones I did on the previous page. I've just now actually gone and drawn the full structures, full structural formulas to make sure you had them correct, and then I've also given the names written a bit better with a few scribbles to try and show clearly where the groups are and how the numbering works. All right, hopefully you got that correct. Again, this is just trying to show you that this could be your longest chain, or that could be your longest chain in this one. But an ethyl is a 2 carbon branch. Right, we're going to run through cyclic alkanes. Actually, no, I don't. I think we'll stop there. We'll come back and do a separate video for cyclic alkanes. Why don't you go and do some examples now? There's probably a lot more of the examples in the notes that you can actually do. You can possibly do some in the book as well, and probably some more in the worksheet. So now you can really get into some examples, try some naming as best as you can. I'll try and put up another little worksheet here with some answers just for you to practice some naming, some more naming. Do as much practice as you can, and then when you think you're getting somewhere with the naming, and then move on. And then I'll do a short little video on cyclic, and then we'll get into the reactions of each of the homologous series. All right, so I really hope this video helps and you feel you're getting somewhere. Don't forget to ask questions of your teachers during your team sessions when you get the chance. Okay, so cheerio for now.